Here's just a few notations that you need to be aware of. We said before that f prime meant derivative. Well, these notations as well mean derivative. This is y prime. So you may be given, instead of f of x, you're given y is equal to an equation, and it says find the derivative. Well, you can notate that as y prime instead of f prime. And the same thing goes for any other, let's say g of x. The derivative would be g prime of x. So that prime always notates a first derivative. The other notation you'll see is dy over dx. It's not a fraction, but it's a notation that you're taking the derivative of y with respect to x. So this is the derivative of y with respect to x. And that'll make more sense later when we do a bunch of other different types of derivatives. But right now you're taking the derivative of y with respect to x. Now these three other notations here, specifically the last two, these last two aren't as common, but if you do see that in your textbook or in some worksheets and you see, okay, find the derivative of y with respect to x or find the derivative of f of x, this is what they mean. And the same thing here, the derivative of x of f of x. So just be mindful of the notation. Don't get alarmed by it. These are the most common notations that you will see. Also, was mentioned before when we did the example, if you plugged in or substituted a value for a, and that being x, so you substitute a value for x, realize that that number that you substitute in there, f prime of a, into the derivative, is the slope of the line tangent to the function at the point a comma f of a. Remember, this is x f of x. Okay, so they're just using a so that you don't get confused with the idea of x. So just realize that the derivative, once you substitute a value in, actually gives you the slope at that x value, at that point. Now this example here encompasses a wide range of items that you need to be comfortable doing and working with. So let's read the question. It says find the equation of the tangent line to the graph f of x is equal to 2x squared plus 2x plus 3 at 1, 7. Something new here. We're asking you to find the equation of the tangent line. So not necessarily the slope, only the slope. But you're going to have to find the slope in order to find the equation. Because remember, if we use the point slope formula, all you are missing right now is because you have a point, right? So you have your x1 and your y1. You're missing your slope. So you just have to find that. Substitute then the values in at the end. So your first step, find the slope. Once you find the slope of the tangent line at the point, you then can substitute the slope in of that tangent line along with the 1 and 7. Because also, why can you use 1 and 7? They want you to find this tangent line at that point. Remember what a tangent line, it goes through at one point? Well, that's the point they're telling you. So you have all the pieces to answer it. So let's go ahead and answer it. I need to use the derivative law. So remember, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Remember, this is the slope of the tangent line. Let's first start by finding f of x plus h. This one's a little more difficult than other ones we've seen. So everywhere there's an x, you're putting x plus h. 2 parentheses x plus h squared plus 2 parentheses x plus h plus 3. Notice that I like to do the f of x plus h outside of the limit rule. Reason being is I don't want to keep rewriting limit in front each time. So I find that if I take the work to the side, I can always then just substitute it in, and it's a little bit less work to write in the rule. But you can place it in right away if you like. Remember earlier I told you to memorize what this x plus h squared is. So assuming that we remember that, that's x squared plus 2xh plus h squared. That 2 that was in front of the parentheses stays there. Now you can distribute the 2 in front of the second term into the parentheses. So that's 2x, 2h plus 3. And lastly, distribute the 2 in front of the first parentheses. So f of x plus h is 2x squared plus 4xh plus 2h squared plus 2x plus 2h plus 3. That entire polynomial is what we're placing into the spot of f of x plus h. minus f of x. Now you're subtracting the whole trinomial. So let's write this out. Need a little bit of space. Hopefully I can squeeze it all in here so that way we don't need more. So this becomes the limit as h approaches 0. F of x plus h again. 1, 2, 3, 4, 5, 6 terms. I'm going to write it out. 2x squared plus 4xh plus 2h squared plus 2x plus 2h plus 3. That's only f of x plus h. Now I have to subtract f of x. So minus 2x squared plus 2x plus 3. I'm squeezing it in here, but realize what I'm writing. F of x plus h minus f of x in parentheses all over h. My next step, do I need a parentheses? I do. I have to distribute that negative in. So I'm going to write this now instead. Since I know what f of x plus h is, I'm going to erase this portion so that way I have a little bit more space. The limit as h approaches 0 of 2x squared plus 4xh plus 2h squared plus 2x plus 2h plus 3 minus, distribute that negative, minus 2x squared minus 2x minus 3 all over h. Anything that doesn't have an h should simplify and go to 0. So let's see, do I have a 2x squared and a minus 2x squared? I do. Leave the 4xh alone. Leave the 2h squared alone. Do I have a 2x and a minus 2x? I do. Leave the 2h alone. Do I have a 3 and a minus 3? I do. Notice that the entire f of x is what results in the simplifying of the f of x plus h. That should always happen. Now, the limit as h approaches 0 of 4xh, I'm just rewriting what's left, plus 2h squared plus 2h all over h. What's your next step? Factor out the h. Limit as h approaches 0. 4x plus 2h plus 2 all over h. Boom, boom. Limit. I keep writing it over and over again. It's okay. You have to. You should. So you know what you're doing. Now, here's the key. Go back to the foundation of limits. H approaches 0. So wherever you see an h, put a 0. So this becomes 4x, x is an h. H is only here with a 2. Plus 2 times 0 plus 2. So it's that term that goes to 0. And you're left with the 4x plus 2. It's good. What did we just find? Oh, that's right. We were finding f prime of x, which gives you the general equation for all the slopes of tangent lines at a point. I need more board space, so we're going to erase a little bit. So, we found f prime of x. F prime of x is 4x plus 2. Okay, now, we want to know the slope of the tangent line at the point 1, 7. So f prime of 1, because that's the x value, is equal to 4 times 1 plus 2. So the slope of the tangent line at 1 is 4 plus 2, which is 6. It's the slope of the tangent line at 1, 1. Was that the question, though? The question asked you to find the equation of the tangent line. Ah, we're almost there, because here is where you finish. Y minus y1. What's y1? 7. Equals, what's m? 6. X minus, what's x? 1. You can leave your answer like that, and it's correct. Or, if you want to write it in slope-intercept form, and you don't want to use that either, let's say you just want to go right into slope-intercept form, your answer should be y is equal to 6x minus 6. I distribute the 6. I add the 7, which means my final answer is 6x plus 1. So this is the equation of the tangent line to the curve f of x is equal to 2x squared plus 2x plus 3 at the point 1, 7. And this is how you go about answering it. Find a derivative, f prime of x. Substitute inside of f prime of x, substitute the x value to find the derivative, the slope of the tangent line at that point. Then take that slope, this is your m, take that slope and substitute it into the point slope formula as well as the point 1, 7.